Hello guys. So in this video, we are going to be finding out molecular, total, or complete ionic and net ionic equations for two separate equations. So for two separate reactions. For the first reaction, we have a precipitate, and for the second reaction, we have an acid-base reaction. So, uh, it, like the first uh, uh, rule of thumb in any equation or any question, especially in chemistry, is going to be finding out the cations and anions if ionic molecules are present. So for the first one, we got sodium hydroxide. For sodium hydroxide, sodium is going to be Na2 plus, and hydroxide is going to be OH minus. For copper 2 sulfate is going to be Cu2 plus and Cl minus. So we got our cations and anions for both the reactants, and now we can actually start writing down our equation. So for this one, it is NaOH aqueous plus CuCl2 aqueous. That gives us NaCl aqueous plus CuOH2 solid. So it's very important to know why something is aqueous and why something is not. So NaOH and CuCl2 both are ionic and are soluble. So they dissociate and are in the form of aqueous solutions. Same with NaCl. NaCl is ionic, and if you refer the table we have, it is also soluble. So it gives us aqueous. CuOH, so that's going to be copper hydroxide. That is actually insoluble, even though it is ionic, it is insoluble at a precipitated form, so it remains as solid. So this equation up here, it is not balanced. So our first step for our molecular equation is going to be getting a balance equation. So to balance it out, we need to have the same amount of molecules on each side, or atoms or elements on each side of the equation. So it's gonna be uh 2 NaOH aqueous plus CuCl2 aqueous. That gives us 2 NaCl aqueous plus CuOH2, that is solid. So now for the net total ionic equation or the complete ionic equation, we need to write out all the cations and anions present in this in the equation above. So for that one, we have 2 Na plus plus OH minus 1. Sorry, it is 2 OH minus plus Cu2 plus C 2Cl minus, and on the product side we have again 2Na plus plus 2Cl minus, and then so this is the precipitate form and it's a solid. So the rule is that solids, liquids, and gases do not dissociate in a precipitate or this form of reaction. So in acid bases, water doesn't dissociate because it's a liquid. In this one, CuOH is solid, so it won't dissociate, and we don't need to break it down further. So this is going to be our total ionic equation. For our net ionic equation, we need to cancel out the same ions on both sides of the equation. So For the first one, we have 2 Na plus. We have 2 Na plus on both sides. Then we also got uh 2 Cl minus on both sides, and the rest we don't have any other left. So as our net ionic equation, we have 2OH minus plus Cu2 plus. That gives us CuOH to solid. So in this equation, a precipitate is formed, and when a precipitate is formed, the precipitate doesn't dissociate because it's a solid form, so it doesn't dissociate. And this is the process of finding out the molecular equation, total ionic equation, and net ionic equation for a precipitate reaction. In our next question here, this is going to be an acid-base reaction. So a precipitate is not going to be formed. Instead, water is going to be formed, and we're going to find out how. So again, the uh, first thing to ever do, step zero, is finding out both cations and anions in the equation. So we have right here calcium hydroxide. Calcium is going to be Ca2 plus, and hydroxide is going to be OH minus. For nitric acid isn't going to be molecular, but it is part of the 7 strong acids that dissociate in water in aqueous solutions. So we still have to write it down. So that's going to be H plus and NO3 minus. So again, time to write our molecular equation. It is going to be CaOH2 is going to be aqueous, plus HNO3. That is going to be aqueous as well, as it's a strong acid. Then we got Ca and O3 2 plus, uh, this is going to be aqueous as well, plus 2 H2O, that's going to be a liquid. So calcium uh, hydroxide is aqueous is because it's ionic and it is soluble. So it dissociates. The same over here. So calcium nitrate is also aqueous and it dissociates. H2O is liquid, so it doesn't dissociate, and HNO3 is a strong acid. It's just part of the strong 7 acids, and they do associate, even though they are molecular. But this equation above, it is not balanced, so we have to balance this out and write down the proper molecular equation below. So to balance it out, we need to have the same amount of molecules or atoms on both sides. So it's gonna be CaOH2 aqueous plus 2HNO3 aqueous. That gives us CaNO3 2 aqueous again plus H 2H2O liquid. So this is our molecular equation. So for the total ionic equation, we need to find out the total ions or all the ions that are present in this equation. We have to break it down again. And then by doing that, we get Ca2 plus 2 OH minus plus 2H plus. So 2H NO3, the two distributes among both among the H plus ion and the NO3 minus ion. So 2H plus 2 NO3 minus, that gives us Ca2 plus again plus 2 NO3 minus plus 2 H2O. Again, H2O is liquid, so it won't dissociate, and water doesn't dissociate in general. Things do dissociate in water, but water doesn't dissociate itself. Well, not up till now, I don't know. So that is going to be our total ionic equation. We have all our ions separated in this equation. For the net ionic, we will cancel out all the same ones on each side. So if we see Ca2 plus right here is the same as Ca2 plus right here. 2NO3 minus is over here, and 2NO3 minus is over here as well. So everything that is left behind is going to be, let me, so everything that's left behind is going to be 2OH minus plus 2H plus. That gives us 2H2O. That's it. So this can be further simplified, and our final net ionic equation is going to be OH minus plus H plus. That gives us H2O. So in this video, we found out uh, the molecular equation, total ionic equation, and net ionic equation for two different reactions. First one being a precipitate that leaves behind us a salt or a different element, and then the second one is going to be an acid base, and the acid at the end of the acid base one, H2O or water is left behind. Thank you very much.